I'm Siva sir. Today we are going to discuss about electricity. Electricity topic we are going to discuss. So in the morning live class, see you can observe once morning live class. You can check once. In the morning live class, you can check once. The morning live class, you can check once. In the morning live class, I explained about like electricity problems. So completely electricity problems I explained. Now in this live class, so we are going to discuss about problems related to electricity. Problems related to electricity we'll discuss. So everyone be ready with the pen and book. Will work out. Okay. So in this, so start with see. Mainly we'll discuss with circuit problems first. Circuit problems only. After that we'll go with the one by one problems. Okay. So few questions are repeated questions are there. Repeated questions. Those are very important. So one by one, step by step, I will go to circuit problems. So simple to advanced level will work out. Okay, simple from basics to advanced level circuit problems will do it. Then related to circuit problems, what are the questions they will ask in exam? Those questions also will do it. Those questions also will do it. Okay, after completion of that, we'll work out on remaining problems. So in circuit, in electricity, there are so many problems are there. So many problems. So we need to discuss. That's the reason every day few problems will do it. So we may not do all the problems, but we will try to do some problems which are related to circuit. Okay. Not only circuit related problems, remaining problems are there. Those also will work out on it. One question I'll tell related to circuit problems only. Related to circuit problem. But so how they will ask? In the form of question. In the form of question they will ask. In the form of question they will ask. So circuit problems only in the form of questions. So how they will ask? How they will ask, we'll discuss. I'll write the question, try to solve it. So here, question, if you are taking question. So four resistances, four resistance, four resistance of 2 ohm each, of 2 ohm each, of 2 ohm each are are joined, are joined, are joined to form a square ABCD, square ABCD. Calculate the equivalent resistance, the equivalent resistance of the combination between any two adjacent corners, any two adjacent corners. Okay, so here you have to understand So this is the question. This is the hi sir, how are you, sir? Sir, you sound. Never seen a teacher who can teach us when no one is watching. Respect, sir. We are watching. Yes, ma'am. Thank you so much. Okay, so here you can see. So I'm talking about here. You can observe four resistance of 2 ohm each are joined to form a square ABCD. Are you? So there is a square. Okay, so square is here. I'm taking like this. So this is one, and here on more I'm taking like this, and here I'm considering so like this, and here I'm considering like this. Okay, so to form a square, so this is square, this is square. Okay, this is square they're given. So we need to find out. Equivalent resistance. We need to find out equivalent resistance between adjacent corners. Adjacent corners we need to find out. How to find out? How to find out? How to find out? Can anyone say? How to find out? So here you can see I'm taking these two. So you can see these two I'm taking. So this is one. This is one. A, B, C, D. Or you can say A, B, C, D also fine. So hi, Sunita Dev, hi. Oh, here you are considering here. I'm considering like this. We can take any order. It's fine. So they mentioned the order. They mentioned the order. Here I'm taking A, B, C, D. I'm taking this order. So four resistance. So one, two, three, four. I have 2 ohm resistance. So 2 ohm you have to take. So each resistance is 2 ohm. So I am taking this is 2 ohm, and this is 2 ohm, and this is 2 ohm, and this one is 2 ohm. Okay. So calculate the equivalent resistance of the combination between any two adjacent corners. Any two adjacent corners. So we have to find out. Here we need to find out. Okay, so here we have to find out. What we have to find out? The combination, the equivalent resistance between two adjacent corners. Equivalent resistance between any two adjacent corners. Any two adjacent corners. You select any two adjacent corners. So here equivalent resistance between any two they mention here, any two. So underline this word, any two. We can take here to here, this one, between these two, or between these two, or between these two. We can try anything. So we can try anything, right? So we can take any two adjacent corners. We can take, so between any two adjacent corners we have to consider. So the point is how you are considering. Is very important. So the way we consider. Okay. So now I am considering the order. So I want to find out equivalent resistance between A and B. So I want to find out equivalent resistance between, so 2 points. AB I am selecting between A and B. So between A and B, so A and B I'm selecting. Now you see, so between A and B if you are selecting, okay. So remaining, so these three resistors, 2 plus 3. So these 3 resistors are in series combination. Sir, how you can say these 3 are in series combination? So according to the rule, so if the current is same throughout the path, so if the current is same throughout the resistors, so those are connected in series combination. Even though those are connected, so you can take this right word. So best example, I am taking one resistor here. So I am considering So best example you can observe here. I am taking one resistor like this. So I am taking one more resistor like this. One more I am taking. So these three resistors I bent like in this way. So I bent in this way. Okay. So I bent. So there is no change, right? Same current will flow. Same current will flow. Even here also same current will flow. No change in the current. Myopia. Okay. We'll see. So not now. Okay, same current will flow, so current won't change. Current will pass throughout the circuit same. Current will pass throughout the circuit is same. So that's why we are taking, that's why we are considering. So those three are connected in series combination. So those three are connected in series combination. So I am taking these three are connected in series combination. So then we can say, then we are considering, so you can observe, so 2 plus 2 plus 2, that is 6. So that is 6 I am taking. Now the final resistance, if you want to find out, we have to redraw the diagram. So this is A and this is B, and I am considering this is 2 plus 2 plus 2, so that is 6. So 2 plus 2, 6 I am taking here. Shivani. Sir, how we will know if they are in parallel or in series in this type of questions? So got confused. So nothing much, simple, very easy. I already said. So where you have to understand, whether those resistors are connected in series or not. If you want to check, so select two resistors. Those are in a continuous manner, not junction. Don't select in a junction manner. So if you select in junction, you will get confusion. So select where two resistors are connected one to one. Only that one. So current must be passed in the two resistors, must be same. So I am taking these two resistors. So I want to find out equivalent resistance between these two. So remaining resistors, how it is? So I already set the format. So like this I connected, like this connected, and like this also connected. Okay. So here the current throughout three resistors, current is same, right? Current is not changing. Current is same only. Current is not changing. So if junction is there, if the junction is there only, then the current will be divided. Okay. So if junction is there, like if you're taking like this, okay, and here I'm considering like this, and if you're taking like this, so if the current is passing, so it is dividing into two parts. So one current, so I1 current, if you're taking total current is I, so some of the current is going this way, some of the current is going in that way. If it is dividing, then we can say the current, no, though resistors are connected in parallel combination. So if the current is passing through these current is passing in the junction, then what happens? So one time it will go like this, another time it will go like this. So half of the current, so we don't know, so some of the current will go. If it is dividing, then these two resistors are connected in series parallel combination. So if the current is not dividing, okay, so current is not splitting. If the current is not splitting, then that combination is called series combination. Here you can see, so current is passing continuously, there is no division. So current is not dividing, then it is series combination. So here I am taking 1, 2, 3. So these three resistors are connected in series combination. How can we say? Because current is same. So current is same. So through all these three resistors. So that's why I'm taking 6. Is it clear, Shivani? Now, so redraw the diagram. I'm redrawing the diagram. You can check once. So I'm redrawing the diagram. Now you can observe. So then in a triangle combination, how can we solve? Triangle, I will tell that question also I'll give. After this one, I will give one more question. There I will explain how to solve. Now you can observe here. So I am taking current is passing like this. Next question I will give that only, Shivani. Next question I will draw that triangle question and also how to solve it, how to take it. Okay, one by one we are going, right? So this starting level until advanced level will go. So now you can see. So if you are taking these two are in parallel, how if the current is passing, so here it is dividing and here also it is dividing. Some of the current is dividing through and passing through 6 ohm resistors and some of the current is passing to 2 ohm resistors. So these two are in parallel combination. So 1 by Rp equal to 1 by R1 plus 1 by R2. So then we can say 1 by 6 plus 1 by 2. So that is nothing but 1 by Rp equal to, so we can take 6 LCM and 1 plus 3, that is nothing but 4 by 6. Now we can take Rp if you are considering Rp. Rp is nothing but 6 by 4. 6 by 4 is nothing but 1.5, I hope. Okay. So that is the answer. Resistance in overall resistance in this combination between any adjacent two corners. See, 1 point. So 4 1 ja, 4 2 ja, 4 5 ja, 20. So yes, correct only. So any two adjacent corners you can consider. Any two adjacent corners. It's not only one we can take. So we can take. So I already said between these two we can solve. 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 So between any two adjacent corners you can take. So if you take it, so suppose I am considering between these two corners, remaining these three are in series combination. Again same formula. So between these two corners, again these three are in series combinations. Again same formula. Between these two resistors, again these three are in series combination. Again same formula. So between any two adjacent corners, don't waste students' time with the. So I am considering like this. So with that we can do the problems. Okay, so next one more I'm doing. So one more I'm considering here. So one more. So do we always have to do the reciprocal of answer we get in parallel? Yeah, compulsory. So here the parallel formula is 1 by Rp. So normally we are taking 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we need to find out the equivalent resistance. So finally we need a resistance. So we don't want 1 by Rp. So we want only Rp. So after solving, so if you are taking this one, after solving you will get some value in 1 by Rp format. 1 by Rp format. So now we solved 1 by, see here I will tell 1 by Rp equal to, so I got 1 by 6 plus 1 by 2, that is nothing but 6. So 1 plus 3, that is nothing but 4 by 6, that is nothing but 1 by Rp. Rp equal to, so here whatever we got, so here 1 by 2 2 ja, 2 3 ja. Suppose you take like this. So this is the value of 1 by Rp. I want Rp. So 3 by 2. So 3 by 2, that is nothing but 1.5. So 3 by 2, that is nothing but 1.5. So I want only Rp value. Nothing but R value. I want equivalent resistance in combination. Understood? So that is the answer. So one more problem, I'll do it. So one more problem. Okay, so we are going to the next one. So next one I'll solve here. This question. So problems, as I said, yes, this is a triangle format. So in triangle, I'll do it. So I'm considering here. So okay, Daniel. So we are doing few problems, right? Let me finish it. So we'll go through it. Okay. So don't worry about it. We will do the problems. Okay. Those are not related to. Sometimes they'll get confused because this format is different. That format is different, right? That is the reason. So we'll do. Don't worry about it. I'll solve. Not now. We'll work out. So few methods. We are going with the different methods. So we'll work out on now. So I'm considering here, so positive, negative, current is flowing like this, and I'm considering here. So here I'm considering, so now you can consider. So here you can see, this is A, B, C, D and E. So this is 0.5. So this is 0.5, and here 3 ohm, and here is 3 ohm, and here is 3 ohm. So current is passing from positive terminal to negative terminal. Now you can observe in this case, so in this type of, okay, so problems, so I'll explain, just observe. So Daniel, I am responding to your message only, definitely I'll do it, okay. So we are working in one few methods, so on these methods we'll do it. Later I'll explain. Otherwise you can, anyway you can contact me. So remaining classes, so that time I will explain that. So don't worry about it. I'll explain. First we'll work out on this problem. Okay. Now you can see I'm talking like this. Okay. We are taking. So these two are in series. These two are in series. These two are in series. Right? How can we say these two are in series? How can you say these two are in series? How can you say these two are in series? So here I'm considering like this. So how can we say these two are in series? So current is passing from here. So through this end until here, current is passing in the same, right? So whatever the current is flowing from here to here or from here to here, same current is flowing. Okay, so why? Because those two are connected in series combination. Those two are connected in series combination. Those two are connected in series combination. That's why we are taking. So series combination. That's why we are taking series combination. So if your two resistors are in series combination, if two resistors are connected in series combination, series combination, what we have to do? We have to add all those two resistors. If two resistors are connected in series combination, we have to add all those two resistors. Now you can see, every time when you are drawing, every time when you are solving the problem, when you are solving the circuit problems, so you must add and redraw the diagram. So redraw this. I'm redrawing the diagram. Check once here. So I'm taking ammeter here. So positive, negative I'm taking here, and this also. So here I'm considering like this, and here I'm considering like this. So here also I'm considering. Okay. So these two, whatever two resistors you are adding. So how much you got? 6. So here is a 6 ohm. The final answer you have to write. You no need to write again adding those two resistors and taking 3 plus 3. So no need. Just directly how much ever you got. So 3 plus 3 after adding how much you got. So 3 plus 3. Then you got 6 ohm. So 3 plus 3 you got 6 ohm. 3 plus 3 how much? 6. So you can directly write here. That's enough. So now I'm considering here 3 and here 0.5 and here also 0.5. So 0.5. Now you can see, so these two are in series or parallel? These two are in series or parallel? So parallel. How? If the current is passing through this, whether it is dividing or same current. whether current is dividing or not, we have to check. So if the current is passing through this one, so if I am taking here I1 and I2, so current is dividing into two parts. Current is dividing into two parts. So we have to take these two are in parallel combination. These two are in parallel combination. If resistors are in parallel combination, if resistors are in parallel combination, if resistors are in parallel combination, then what we have to do? If resistors are in parallel combination, so 1 by Rp equal to 1 by R1 plus 1 by R2. So you have to do parallel combination formula. That is nothing but 1 by Rp equal to 1 by 6 plus 1 by 3. So 1 by 6 plus 1 by 3, how much? So we can take, so how much we got? So now you can observe 1 by Rp equal to 1 by 6 plus 1 by 3. So we got 6, that is nothing but 1 plus 2. So now 1 by Rp equal to, so 3 by 6. So Rp equal to 6 by 3, that is nothing but 2 ohm. So Rp is 2 ohm. We need, say already said every time saying, if it is in a parallel combination after solving, after final answer, so here from this one, so after solving this also you will get 1 by 2, 3 1 ja, 3 2 ja. So we don't want 1 by Rp. We want only Rp value. So better you have to write in a reverse format. That is Rp value. So Rp value is 2. So we want only Rp value. So keep in mind, sometimes what students do mistakes, after solving here 1 by 2, there is nothing but 0.5. So 0.5 only will add. So 0.5 plus 0.5, 0.5. Then it will be wrong. 1.5 you will get. So completely answer is wrong. So we should not do like that. So we want the final answer must be in resistance. Not 1 by Rp. So it must be in Rp value. It must be in R. It must be in R. So keep that one in mind. Very, very important. So many of students, so with the experience of 10 years, I am saying, so many of students they will do mistake in this area itself, in this area only. So they will solve until here. They will do excellent, extraordinary, marvelous. So extraordinary way they will do. Even also how difficulty they will give diagram also, they will solve in easy way. The point is after solving, so they will take 1 by Rp value. 1 by Rp value. So 1 by Rp value they will take. They won't take R value. So final we want only R value. We don't want 1 by Rp. We want only R value. So make it mandatory. R value only you have to consider. So take it R value. Now you are considering, again redraw the diagram. If you are redrawing the diagram, so again I am considering here. So if you redraw the diagram like this, okay, so I'm considering here, so positive terminal, negative terminal, so again ammeter here and switch. So here I'm considering positive, negative, current is flowing. So here you can see, after solving this one you got 2, right? After solving this one you got, how much you got? 2. Correct or not? After solving this value, so after solving 1 by Rp, that is 1 by 6 plus 1 by 3. 1 by 6 plus 1 by 3. So after solving you got 2 value, right? So we have to take the 2 value here. So if we have to remove, we should not take it like that also. What are the resistors? Whatever resistor you got, that you have to add to the remaining resistors. Whatever you got the value, that value you have to add to the remaining resistors. So then you will, how much we got? So 2. So how much we got? 2. Here how much? 0.5. Here also how much? 0.5. So these 3 resistors are in series or parallel? So 1, 2, 3 resistors are in series combination. Why? How can you say these 3 resistors are in series combination? So the current is same. Throughout the 3 resistors. So that's why those 3 resistors you have to consider in series combination. So now you can take, so 0. Plus 2 plus 0.5. So now you are considering, so now you can take 0.5 plus 2 plus 0.5. So how much total value? That is R value only. So in series combination, so you no need to do anything. If it is in resistors are in series combination, resistors are in series combination, resistors are in series combination, you don't need to do anything. Just add all the resistors. That's enough. All the resistance. So now I am considering. So 0.5 plus 0.1. So 1 plus 2 is 3. So the answer is 3 ohm. Answer is 3 ohm. Answer is 3 ohm. So that is the answer. That is the answer. That is the answer. That is a resistance. Total equivalent resistance. Equivalent resistance. So once again, I will be explaining just to focus on it. Focus on it. So here I am considering. I am taking 1, 2, 3, 4, 5. 5 resistors. 5 resistors. They given in that format. They given in that format. See, these two resistors we have to consider in series combination. So why we have to consider series combination? Because current is same. Current is same. These three resistors. Current is same throughout these two resistors. These two resistors. Okay. So 1, 2. So these two resistors current is same. So that's why I'm adding 3 plus 3. That is 6. Then you got C. So here you got 6. 6 ohm resistor is connected to 3 ohm resistor. So in the parallel combination. So in the parallel combination, 6 ohm resistor is connected to 3 ohm resistor in the format of parallel combination. Parallel combination. So 1 by 6 plus 1 by 3. 1 by 6 plus 1 by 3. After solving 1 by 6 plus 1 by 3, you got 3 by 6. You got 3 by 6. So we want in the format of R. So we don't want 1 by R. We want only R value. We want only R value. We don't want 1 by R value. So keep in mind, only when you are adding to the next resistors, when you are taking the parallel combination, compulsory, see, every time you can see the series formula, parallel formula. So series, if you are taking R1 plus R2 plus R3. So we are taking only this. R1 value we want. We are not substituting 1 by R value, right? We are not substituting 1 by R value. Even in the parallel combination also, 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R3. So we are even here also you are substituting R value. You are substituting R value. Don't get confused. So you have to take in the C, if they give problem, we will check all the units are there in the SI system or not. SI system or not. Here also same thing. Here also same thing. After solving the parallel combination, especially in parallel combination, after solving the value, so better be careful. So be very careful. So while writing the value, whether you are taking 1 by R value or R value. 1 by R value or R value. So you have to take R value. Question is this only. This is the question. So you have to find out equivalent resistance. Equivalent resistance throughout the circuit. This is the question. So this is the question. Okay. So this is the question. Okay. Now, so after solving here, after doing that one, you got to 2. So you got 2. So 0.5 plus 2 plus 0.5. 0.5 plus 0.5, that is 1. So plus 2. So 3. Total answer is 3. Okay, na? So that is equivalent resistance. Now we are finding only, okay, so R value. Now we are finding only R value. Now we are finding only R value. So find out only R value. So later 1 by 1. Later after that current we have to find out. After that so potential difference we have to find out. Like different kinds of questions we will solve. Different kinds of questions we will solve. So slowly we'll go to the next level. Slowly there are many problems. So higher standards also there. So one by one, slowly one by one, we'll go to the higher level. So next level, step by step, we will increase. Now we are doing. So only resistance we have to find out. If they give circuit, how to find out resistance? After finding resistance, if they ask current, V equal to IR formula, potential difference anyway they will give. Potential difference will get. Anyway, resistance you are finding. So definitely you'll get. So major thing is generally, so if circuit related problems, if they ask in the exam circuit related problem, surely they will ask about finding the equivalent resistance. Generally they will ask equivalent resistance. So after that if they want to give next level, they will ask about current. After that still one more level, potential difference across particular resistors. So they will give a particular across particular resistance. Okay, so they will connect a voltmeter, find the potential difference across this voltmeter, sorry, across this particular resistor, like that they will ask. Okay, so those type of questions they will ask. So we'll do it now. So I'm going to the one more question. Try to solve this question. So one more question. I'll give one more question. Try to solve it. So now you can see. Now you can see I'm taking this is the question. So this is the question. So current is passing. So current is passing like this. Okay. So yes. This is the question. So they're asking to find out. They're asking to find out equivalent resistance. How to find out equivalent resistance? Can you tell me? Can you tell me anyone? Anyone can you tell me how to find out? Here I will tell how I will tell in a simple method. So we have to find out overall equivalent resistance, effective resistance throughout the circuit. Okay, so this is the step I will tell. I'll tell 3 points. Point number 1, select 2 resistors. Select 2 resistors. Select 2 resistors. Identify the current. So you have to check the current. Okay. So third one, do accordingly. Parallel, series. Series or parallel. Okay. So here you see, select 2 resistors. Compulsory you have to select 2 resistors. So now I am selecting these 2 resistors. So why I am taking these 2 resistors? Why I am taking these 2 resistors only? Why can't I go for these 2? And why can't I go for see? I'm selecting these 2 resistors. I'm selecting these 2 resistors. What is the reason? What is the reason behind of this? Only sir, you are selecting only these 2. Why can't you go for this one and this one? Why can't you go for this one and this one? Why can't you go for this one and this one? And why can't you go for this one and this one? So I already said select 2 resistors. So how to select? So in the such way current must be same. If you are selecting 2 resistors, in that current must be same. So I am selecting these 2 resistors. So current, you can take current in this direction. Start from here. If the current is passing, so throughout this path, or enter this path, current is same or not? Current is same or not? Or current is different? Current is same or different? Current is same. Current is same, right? Current is same in this path. Current is same in this path. So you can add these 2 resistors, R2 plus R3. So you can add these 2 resistors. If you are adding these 2 resistors, how much you'll get? If you after adding these 2 resistors, how much you'll get? You will get, so 3 plus 3. So sorry, 3, right? Total 3. So each and every one is 3. Okay, each and every resistor is 3. So I'm considering here. Okay. I'm considering now. This is 3, 3, 3, 3, 3. So you try. So this is 3, 3, 3, and 3, 3 ohm. This is also 3 ohm, and this also 3 ohm. So they given here. So all are with 3 resistance only. R1, R2, R3, R4. So each and everything is R only. Everything is R only. So in that case, so I'm selecting 2 resistors. I'm selecting 2 resistors. R2 and R3. I'm selecting these 2 resistors. Those 2 resistors are in series combination. So I'm adding those 2 resistors. Next one, see, identify the current and series or parallel. So if it is series, add parallel. So follow the same formula. That's enough. So that's the process. Now I am taking here, you can see. So now you can consider, now you can observe, I added this 2 resistance. How much? So 3 plus 3 is 6. And here 3. And here 3, 3 again. So current passing, so here. Every time you have to redraw the diagram. That is compulsory. Every time when you are drawing, you must redraw the diagram. So here again these two are in series or parallel. Again these two are in series or parallel. So that's why 1 by Rp equal to 1 by 3 plus 1 by 6. That is 6, 2 plus 3. Oh, so 2 plus 1, sorry. 2 plus 1, 2 plus 1, 2 plus 1, 2 plus 1. 3 by 6. That is 1 by Rp. 3 by 6. Rp equal to 6 by 3. That is nothing but 2 ohm. Rp equal to 2 ohm. Rp equal to 2 ohm. Right? Correct? Rp equal to 2 ohm or not? Yes or no? Yes or no? You got it right? So Rp equal to. Again after redrawing diagram, how it will become, you check. So now I am considering. Again you observe here. How much you got. Again you hear how much you. So here how much you got? Tell me. Can you let me know? No? So how much here? 3 plus 3 plus 3. Here how much? 2. So these 3 are in series or parallel? Current is passing here. Current is passing in this combination. So throughout the path, current is same. Throughout the path, current is same. Throughout the path, current is same. So if the throughout the path current is same, so those 3 resistors are in series or parallel. Those 3 resistors are in series or parallel. Series or parallel. So series combination. So then 3 plus 2 plus 3. So now R equal to, so 6 plus 8. 8 ohm. That is the answer. That is the answer. Check once. Anybody? So those who know the answer. If it is correct or wrong, let me know. If it is wrong, if it is correct, just check once. So anybody can tell the answer, correct answer. If it is wrong or correct, you can tell, no problem. I am here only. So if you have any answer, if you have any question, just check once. Check once. Okay. So I hope it is very clear. Once again you can check. So these two are in series combination. These two are in series combination. Compulsory. So I have to select. Answer is already given. No, 8 ohm. Answer is 8 ohm already given here. So now once again you can see these two are in series combination. So I added, so 3 plus 3 6. Again that so 6 ohm resistor is became parallel to 3 ohm resistor. So 6 ohm resistor again became to parallel to the 3 ohm resistor. So again we solved. So 1 by 6 plus 1 by 3, 1 by 6 plus 1 by 3. So 2 plus 1 6. So we got 3. So 3 by 6, 1 by RP equal to 3 by 6. So RP equal to 6 by 3, 6 by 3, so 6 by 3, 6 by 3. So RP equal to 2 ohm you got, 2 ohm you got. So whatever you got that resistor, so that resistor to the remaining resistor, so that resistor became series to the remaining resistors. So that resistor became so series to the remaining resistors. Then 3 plus 2 plus 3. 3 plus 2 plus 3. 3 plus 2 plus 3. How much? Total 3 plus 2 plus 3. So that is nothing but 8. 8 ohm. So answer is 8. So like that you have to solve. See, identify the resistors. Identify the resistors. How the current is flowing. Whether it is in series or parallel. Whether it is in series or parallel. Check once. After solving, after identifying, so whether it is in series, add all the resistors. Okay, so resistance, whether it is in parallel, so 1 by Rp equal to 1 by R1 plus 1 by R2. So use that formula. Simple. Okay, na? Series means add all the resistance. Parallel means so you can use the formula. So this is about resistors, series or parallel. Next, one more problem. We'll do it. One more problem. So I'll solve one more problem. One more problem I'm doing. Now you can check. So they're asking to find out equivalent resistance. So we have to find out how much total resistance through this circuit. So how can we find out? How can you redraw the diagram? How to redraw the diagram? Just check once. So I already said. So select two resistors. So I'm selecting two resistors. So I'm selecting these two resistors. These two are in series or parallel. Again, these two are series or parallel. Okay, so these two are in series, these two are in series. So that will become parallel to that one because it's connected to junction. So now I am redrawing the diagram. Check once. So when you are drawing, you can take reset circuit. So switch is there. Now, so you can take, so 3 plus 3, 6 plus 6. Then 1 by 6 plus 1 by 12. Correct? So like that we can take. So now you can consider once again. 1 by RP equal to 1 by, so 3 plus 3, 6. Plus 6 plus 6, 12. So answer is 4. So let me know whether it is correct or wrong. RP equal to 4. So we are solving only effector resistance, equivalent resistance, effector resistance and equivalent resistance. Still we can do current also. Current also stepwise method we are going through it. Stepwise method. If they give circuit problem, if they give circuit, how to identify whether the resistors are in series or parallel? First point. Second point, whether current is flowing. Okay, whether current is flowing throughout the path same or current is dividing. Whether current is dividing or same current is flowing. We have to check. Third one, after identifying the current, we can understand whether it is series or parallel. So definitely if it is series, you can add. If it is parallel, you can use the formula. 1 by RP equal to 1 by R1 plus 1 by R2. So one more problem I'll give. So try to solve it. One more problem I'm giving now. So check once. One more problem. So you try. If you didn't get, I'll tell the answer. So find out R value. So anybody can tell the answer. Try once. Okay, so fine. So I'll teach. You can see here when you are taking this value. Okay, so I already said here I am considering. So two resistors you have to select. I am selecting these two resistors, and these two resistors I am selecting. These two resistors. These two resistors are in series, so you can add these two. These two resistors are in series. Add these two. Then the final output. So every time redraw the diagram. Every time when you are solving the circuit problems without redrawing, so you can't understand. You can't understand how we will get, how to solve also we cannot understand. So thing is, you must redraw the diagram 100%. 100% you should redraw the diagram. Then only it will be correct. Then only it will be correct. So I am redrawing the diagram. So I am taking here. So I am taking this is 10. This is 10. This is 1. So PQ. So now formula is 1 by RP equal to 1 by 10 plus 1 by 1 plus 1 by 10. So how much is LCM? 10 is LCM. So 10 is LCM. So we can take 10. Now here you can take 1 plus 10 plus 1. Right? So now 1 by RP. 1 by RP equal to 10 by 12. RP equal to 10 by 12. That is nothing but 0.83. 0.83. So RP equal to 0.83. This is the answer. This is the answer. Check once. So when you are taking the diagram, so when you are drawing the diagram, compulsory redraw the diagram. Redraw the diagram. Redraw the diagram. Okay. So here you got. So in this case you got 12 by 10. So that is RP. 1 by RP. We want RP. So 10 by 12. So answer is 0.83. So every time again I am saying, every time when you are solving the problem, compulsory redraw the diagram. Compulsory redraw the diagram. Okay. So one time, two time, if you redraw the diagram, so this is the initial diagram. So after adding 7 plus 3, 10. So 6 plus 4, 10. So here is 1. So these three are in parallel combination. So after, if you are not redrawing the diagram, you may not understand how to, whether it is in series or whether it is in parallel. So final output. So compulsory when you are doing this type of problems, try to redraw the diagram. Try to redraw the diagram. Okay. So 10, 1, 10. So 1 by 10 plus 1 by 1 plus 1 by 10. So you are taking LCM 10. So 1 plus 10 plus 1. So then you will get here how much? 12. 12 by 10. So we want we want only 1 by RP equal to 12 by 10. RP equal to 10 by 12. That is nothing but 0.83. 0.83 will get. Answer. Understood? So this is the answer. So 0.83 is the answer. So if you have any concerns related to this question, if you have any doubts, you can ask me. Otherwise, we'll go to the next one. So we are finding the equivalent resistance throughout the circuit problem. One equivalent resistance we have to find out. Then we can go for current. Okay, one more problem. So one more problem. We'll do it. So one more problem. So this is very, very important. Try to answer this question. This is R1. So now you can see. So try to solve this question. So I am considering here this is A to B, A to B. So I have to find out equivalent resistance. So potential difference is given key. Now this is R1, R2, R3, R2, R3, R4, R5. So this is 2 ohm, 3 ohm, 2 ohm, 1 ohm, and here is 2 ohm. Now you can check. So here we need to understand one thing. So I already said select the resistors, whether it is in series or parallel. So identify the resistors, whether it is in series or parallel. After identifying the resistors, whether it is series or parallel, try to after identifying, try to use the formula. If it is series, add all the resistance. If it is parallel, use the formula. So if it is parallel, use this formula. So you can see these three are in series or parallel. Now you can see 1 by Rp equal to, so 1 by 1 plus 1 by 2 plus 1 by 3. 1 by 3. So 1 by 1 plus 1 by 2 plus, because these three are connected in parallel combination. So R2, R3 and R4. R2, R3, R4 are connected in parallel combination. So that's why I'm taking here 6 plus 3 plus 2. So I'm taking how much? 9 plus 1, 11 by 6. So 1 by Rp, that is 1 by Rp equal to 11 by 6. 11 by 6. Rp equal to 6 by 11. 6 by 11. So try to solve in this manner. So you are considering, now you can take, so this is 2, this is 2, so now you can add, that is overall R we want, overall R. So this total, how much you got? R 1, 2, 3. How much you got? 6 by 11. So you got 6 by 11. So how much you got? 6 by 11. So you got 6 by 11. Now 6 by 11 plus 2 plus 2. 2 plus 2. So you can take, because whatever you got that answer, so next remaining all are in series combination. How much you'll get it? Check once. So check once now. So 6 plus 22 plus 22 by 11. Then you'll get 6 plus 44 by 11. Then you'll get 50 by 11. So that is, answer is 50 by 11. Correct? Huh? Check once. So is it clear? So R equal to 50 by 11. R equal to 50 by 11. 50 by 11. Understood? So I hope it is correct. So shall we go to the next one? Next one I will explain. Just check once. So this type of problems they will ask generally. Okay, try to check once whether it is series or parallel. So maximum all formats completed. So then we'll go to the remaining format, finding the questions and the questions with answers. We'll do it. Normal theory questions. Once again, check once. So 1, 2, 3. So three are in a parallel combination. Three are in parallel combination. 1, 2, 3. Three are in parallel combination. So after doing 1 by 1 plus 1 by 2 plus 1 by 3. So take LCM. 6 will get 6 plus 3 plus 2 because here. So simply how much of the LCM you multiply with that 6 by 6, 3 by 3. 2 by 2. So then you'll get 6 plus 3 plus 2. Then you'll get 6 is LCM, 11 by 6. So 9 plus 2, 11, 11 by 6. So 1 by RP equal to 11 by 6, RP equal to 6 by 11. So you can add. So whatever you are getting this total resistance, that will become series to the remaining resistors. Series to the remaining resistors. So then we got 6 by 11 plus 2 plus 2. So 6 plus 22 plus 22 by 11. So 6 plus 44 by 11, then 44 plus 6, 50, 50 by 11. That is the answer. That is the answer. So is it clear? So if you have any doubts, let me know. So then I will explain. So we'll go to the next problem. We'll go to the next problem. So related to circuit based problems, 2 more questions I'll give. So I'll give one more question. So see. So I'm considering here, show how would you connect the 3 resistors. So here, question, show how you would how you would connect would how would you connect 3 resistors 3 resistors each of resistance 6 ohm, so that the combination has a resistance of, so first one is 9 ohm, second one is 4 ohm. Can you do it? Can you do it? So try to do this question. So I'm considering here. Here you can see. Here you can observe. How show how you would. So how you will connect. Where? So how you would connect. Show how you would connect three resistors. Show how you would connect three resistors, each of resistance 6 ohm, so that the combination has a resistance of 9 and 4. So you have to connect. So three resistors given. Okay, three resistors given in such a way that, so I'm giving three resistors. So one, 2, 3. So 6 ohm, 6 ohm, 6 ohm. So I given 1, 2, 3. So 3 6 ohm resistors I given. So you can understand. So by giving three resistors are given. Three resistors are given. Okay. So if three resistors given, how you can connect? How can you connect in such a way that you have to get overall effective resistance. Overall effective resistance. Overall effective resistance you must get either 9 ohm or 4 ohm. Either 9 ohm or 4 ohm. So once again, so I given three resistors. I given three resistors to you. Okay. So three resistors I given. So in this by using those three resistors, by using only those three resistors, you can connect in any direction. So however you connect, you can connect. So here, however you connect, you can connect. So these three resistors you can connect your wish, but the final answer must get either 9 ohm or 9 ohm or 4 ohm. How you will connect? How you will connect? That is my question. That is my question. So one thing I'll tell, 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 one thing I'll tell. Okay, one thing I'll tell. One thing I'll tell. So, however you connect these three resistors, you have to get final answer either 9 ohm or 4, either 9 ohm or 4 ohm, either 9 ohm or 4 ohm. So your choice. You can connect in any way. Okay, so you can connect in any way. So anyways, your choice. Whichever way you want, you can connect. But final answer must be 9 ohm or 4 ohm. 9 ohm or how you will connect, you check once. How you will connect, so you can check once. How you will connect, you can check once. Okay, na? Let me know. Let me know how you will connect. So now I am connecting. Now see here. We know parallel combination. We know parallel combination, series combination. Let me teach in the parallel combination. So I'll connect all 6 in parallel. So if it is series. So let me go with the series. Let me go with the series combination. I'm going with the series. So 1, 2, 3. 6 plus 6 plus 6. How much? So 12 plus 6, 18. 18 is, so 18 answer is there? No. So wrong method. Next parallel. So here 1 by 6, 1 by 6, 1 by 6. So I am taking 1 by 6 plus 1 by 6 plus 1 by 6. That is 1 by RP. Now I am taking 6 LCM. So 1 plus 1 plus 1, that is we get 3 by 6. So that is 1 by RP. RP equal to 6 by 3, that is 2. So answer is there 2. In this, among these two, any one is answer. So how much? So this is also wrong. This method also wrong. This method also wrong. This method also wrong. Right? This is wrong. This one is wrong. So we have to go. We have to go with another method. We have to go with another method. So I'm taking another one. I'm going with another one. Check once. So I'm going to the next method. Next method I'm going. So I'm considering now. So I'm taking this is one. So this is one. So here I'm at 6. Here I'm at 6. Here is I'm at 6. Now you see these two are in parallel. That parallel combination is connected one more resistor in series combination. Okay. So this resistor is connected to this parallel combination. Now 1 by 6. 1 by 6 plus. So 1 by, I'm taking 1 by 6 plus 1 by 6. So 1 by Rp equal to, so 6 I am taking 1 plus 1, that is nothing but 2 by 6. So 1 by Rp. So now Rp equal to 6 by 2, that is nothing but 3. So 3 plus 3. Yes, 9 we got. Correct? 9. 9 is the correct answer, right? So here you can see this you got. So this combination you got 3. So I'm taking here. So this is 6 and 3. So total is 9. Total is 9. Total is 9. Total is 9. Total is 9, right? So total is 9. 9 is answer. So 9 you got, right? Here you got 9. You got 9. That's enough. Simple. So 3 plus 3. So 3 is here. This combination, what are the combination is there here? So if you do that combination, we are getting. So we are getting, so how much we got here? 3. So how much you got here? How much it is? 6. 6 plus 3, 9. So 9 is answer. This is one method. One method. One method we can follow. One more I am going to that. One more I am going to that. So one more method I am going to that. I am going to one more method. So here you can see. So now you can observe 6, 6, 6. So if you add these two, how much you'll get? If you add these two, how much you'll get? 12. So here I'm considering 12. Here 6, 6. So now you can try to solve it. 1 by 12 plus 1 by 6. So 1 by Rp. Now I am taking 6. 1 plus 2. So that is 3 by 12. 3 by 12. 3 by 12. That is Rp equal to 12 by 3. That is nothing but 4. So you got right. You got the answer. So you got the previous method. So to solve, to get these answers, we must follow different methods. Different methods, that is, so six, 6, 6. So check once more. So try to solve it. Okay, check once here now. I hope it is clear to you all. Now we'll go to the next one. So I'm going to the next, try to do it. So like that, different questions are there. Different questions are there. Okay, so we'll see. Show how would you join three resistors, each of resistance. In this question, 9 ohm is given. So in this question, 9 ohm is given. So in the previous question, you can see. So you can see in this question. Now you can go to the next one. Show how you join three resistors, each of resistance 9 ohm, so that equivalent resistance of the combination is. So equal resistance, you can see now. So I'm taking now, here you can see. This is 9, this is 9. Okay, sorry. So same method. So we can follow. So here 3 ohm resistor. So 3 resistors are given. 3 resistors are given. So you can see 1, 2, 9, 9, and the third one is 9. So 3 resistors are given. You have to get equivalent resistance. One is 13.5 and the second one is 6 ohm. So one is 13.5, second one is 6 ohm. How you will get, let me know. Okay. So this problem I'm giving, and again 6 p.m. I am starting class 6 p.m. So again 6 p.m. same we will continue the problems. We'll continue the electricity. Then we'll 9 o'clock also, 6 p.m. and 9 p.m. So problems, because problems are so many are there. So we'll do all problems, electricity. So continuously we'll work out. So you can join at 6 p.m. and 9 p.m. also. So thank you so much. We'll see you in the next class. So hope you like it. Please do like and share and subscribe my channel if you like this like the content. So this is your Siva sir from Student the Brand signing off. Thank you.